Hello everyone, this is Honors Chemistry. This is a little review video. These videos will not last longer than 15 minutes. So this one's on chemical equations. We were working on that before we left for our extended break. So I'm going to cover one video on this, and then we're going to go back tomorrow. We'll be doing a review video. This is for Unit 6 Chemical Equations. And I apologize for the rudimentary setup we got here. If you have not downloaded your exercise that was given on Google Classroom, please download that, stop the video and download that now and work with me as we go through these to figure out what we're doing. If not, that you'll have a hard time following along. So go ahead and get the exercise and go along with me, because I will work some problems with you. But anyway, on your first one here, you have you're trying to figure out how many hydrogens or how many elements of each atom, L of elements are in a molecule. So we know that H2 is a hydrogen gas for A. We know if it's H2, it's got 2 hydrogens. That's all it's asking you to do. 2H2 just means you have 2 molecules of hydrogen gas. So therefore you have 4 hydrogens. You'll notice on your sheet, it's just going to have these listed. You don't have to come up with those already. So you might as well just do it as we do it, okay? C is H2O, which is a water molecule, as we well know. And it has 2 hydrogens and 1 oxygen. So it's simple stuff, right? The next one, D. It has 2 water molecules, 2 H2O. The hydrogen you come up with, 2 times 2 equals a total of 4 hydrogens. Actually, 2 times 1 or a total of 2 oxygens. Easy. The next one is E. It has CaOH2. We know this is lime water. You have 1 calcium. And you have 2 times 1 or 2 oxygens. And 2 times 1, 2 hydrogens. So we have a total of those there. Then you have 2 molecules of lime water. You have 2 times 1 or 2 calciums. You have 2 times 2 for oxygen, because each of these have 2. 2 of those. 2 times 2 is 4. So you have 4 oxygens. Same with hydrogen. You have 2 hydrogens here times 2. 2 times 2 is 4 total hydrogens. So you need to know how to do those. You have to figure those out. Then it goes to G. You have 5. Now we're having 5 lime waters. You have how many calciums you have? 5 times 1 is 5 calciums. How many oxygens you have? You have 5 times 2 or 10 oxygens. How many hydrogens? You have 5 times 2 or 10 hydrogens as well. Then you have calcium carbonate. You have 1 calcium there. You have 1 carbon, and you have 3 oxygens. You don't have to memorize that formula, but you should be able to figure out how to come up with that, with what we've done in class before. But anyway, now we go to I. I has 3 calciums, because you have 3 molecules of calcium carbonate, so you have 3 calciums involved. 3 times 1 or 3 carbons involved. But how many oxygens? You have 3 times 3 or 9 oxygens involved. That's how simple this is. We have a couple more, and then we'll be doing something else. Then our next 2, we have osmium and phosphate. So we have osmium, osmium 3, phosphate 2. So we see we have osmium 3, you have 3 osmiums there. You have phosphate, you have 2 phosphorus, you have 2 times 4 or 8 oxygen in there. You see if you have 5 molecules of osmium phosphate, then how would you do this? You'd have 5 osmiums, and you have 3, it would be 15 osmiums. And phosphorus, you have 2 inside there. 2 times 5 is 10 phosphorus. And here's where it gets a little bit tricky. You have 5, not oxygens, you have 2 of those, but you have 4 of those. So 2 times 4 is 8, times another 5 is 40 oxygens that are inside of 5 molecules of osmium phosphate. So that's really it. Make sure you know how to do these, because this is going to be coming up when we go back to face-to-face. We'll be starting off right here, okay? Now, the rest of the video I'm going to have is going to be just a few balancing chemical equations. But before we do that, we're going to have, this is supposed to be our next, we have to come back to class. This will be our next lab. We'll be coming up with casein, which is a milk protein. All you're going to be doing is coming up with protein, the proteins for milk, by mixing it, whole milk with vinegar, which we'll be pulling out. It's a kind of a stinky lab, but it's kind of fun. So we'll be doing that. That'll be our next lab. But this, I just want to bring that up because I'm showing you how we are using a lot really simple molecules. But there are some very complex molecules. And this is not all that complex, but it is complex enough. It has 38 carbons, as you can see, 57 hydrogens, 9 nitrogens, and 9 oxygens. So this is just an example of a more difficult, a more complex molecule. Okay, now we're going to start with their balancing chemical equations. This one's here. This one would be what you'll be seeing. We did a little bit of this in class, and that's why I want to cover it one more day before we put a close on it for a while. Number one, it says water is produced when a chemical reaction takes place between hydrogen gas and oxygen gas. Write the chemical equation below, then balance it. We already know what hydrogen gas is. It's H2. So you put down below H2 plus O2, because that's oxygen gas, we know that as well, yields water, H2O. But then you have to balance it. You have to have the exact number of hydrogens on one side, has to equal the number of hydrogens on the right side. The number of oxygens on the left side have to be to oxygens on the right side. So that's kind of what you're doing with this. And we did not do this a whole lot in class, so I'm not expecting you to be proficient on this when you get back, but I do want to cover it a little bit, okay? So there's the formula. There's the exact same formula. First thing I told you in class to do, at the yield side, you separate it from the reactants. This is the reactants over here, and these are the products. So reactants are hydrogen gas and oxygen gas, and the product they produce, water. So first of all, you have to find out how much you have to start off with. We have 2 hydrogens here, and we have 2 oxygens here. So list those. Always list the left and the right side on the same order, though. Hydrogens, you have 2 hydrogens, and then you have 1 oxygen. So these all have to be equal. We have 2 hydrogens on the left, 2 on the right. They're good. But we only have 2 oxygens on the left, but we only have 1 oxygen on the right. They have to equal. These whole sides have to equal. So you just have to try numbers and come up with a way to make this equation balance. So I'm going to go through one step by step with you on this. So the first thing you can do, you can say, well, if I have it balanced, I can put 2 water molecules. That will make us have a total of 2 oxygens. So now we have 2 oxygens on the left, 2 on the right, so we're good. But look what else it did. It also gave us, instead of having 2 hydrogens, now we have 4. So now we have 2 hydrogens on the left, but 4 on the right. Oxygens are good, 2 and 2, but we now have to balance it again. So how can we balance that? And the easiest way is you just go ahead and put a 2 in front of the hydrogen gas. So you have 2 molecules of hydrogen gas now. That gives you 2 times 2, 4 hydrogens on the left. 2 times 2, 4 hydrogens on the left. How many oxygens on the left? 1 times 2, 2 oxygens on the left. How many oxygens on the right? 2 times 1 is 2 on the right. So now you have 4 hydrogens on the left, 4 on the right, 2 oxygens on the left, and 2 oxygens on the right. Therefore, it's balanced. So the correct way to balance this chemical equation is 2 hydrogen gas plus 1 oxygen gas yields 2 water molecules. You don't have to put the 1 there if you don't want to. I always like to fill it in, but some people tell you not to put it in, but it doesn't really matter. If you want to put a 1 in, I always do. But so just remember, you don't have to put a 1 there. So once again, you have 4 hydrogens on the left, 2 oxygens on the left, 4 hydrogens on the right, 2 oxygens on the right, so therefore it's balanced. You have another one, this is an easy one, so you're going to have another one by yourself that you're going to have to balance. This one, okay, well okay, here's the one that we finished it. Sorry about that. 2, 1, and 2. So it's completely balanced. 2 hydrogens on the left, 2 times 2 hydrogen molecules, hydrogen gas molecules, 1 oxygen gas molecule yields 2 water molecules. Let's keep going. I think I skipped up on that. Now you're going to have a simple one you're going to have to do. It says sodium reacts with chlorine gas to produce table salt. Write the chemical equation below, then balance it. So you'll see this. Sodium exists by itself, and you should know what the chemical symbol for sodium. So it'll be sodium plus chlorine gas. You should know how to write chlorine gas yields table salt, and you should know the chemical formula for table salt. So you should be able to balance that one. Use the same methods we did in number 1. You should have no problem. Let's go to number 3. Number 3. Oh, how do I get the water again? Oops. Sorry about that. Then we go to sodium. So we know number 3. It says methane gas reacts with oxygen gas to produce carbon dioxide and water. Write the chemical equation below, then balance it. We know methane is CH4. Oxygen gas is O2. Those are the reactants, and they produce carbon dioxide, CO2, plus water. We went over all of these all of these formulas. You have to know the formulas for these molecules. So there, you write that down. Then you have to balance it. First thing you do, come up with how many you have on each side. You have 1 carbon on the left, 4 hydrogen on the left, 2 on the right, 2 oxygens on the left. Make sure you put those in the same order. You have 1 carbon on the left, on the right, excuse me, you have 2 hydrogens on the left, right, and you have 2 plus 1 or 3 oxygens on the right. They're not balanced, so you have 1 and 1, 4 and 2, so they're not balanced, so you have to do some more to it. Then what you can do after you list it down, now what you're trying to do, you've got the carbons are still balanced. Now you put a 2 in front of there to make you have 4 hydrogens on the left. So 2 times 2 is 4. And then you have the oxygens where some people get confused. Carbons are still balanced 1 to 1. Hydrogens are now balanced 4 to 4. But look at the oxygens. You had 4 on the left. You had 3 to start off with, but you had 2 already. You put a 2 in front of that and doesn't change it to 3. That changes it to 4 because you have 2 here and you have 2 here. So 2 plus 2 is 4. Therefore, it's balanced. 1 and 1, 4 and 4, 2 and 4. Excuse me, 2 and 4 is not balanced yet. We have one more step. Sorry about that. And then your last step, I forgot to put a white thing there, so I'll have to put that real quick for you. Sorry about that. To balance that simply, all you have to do is put a 2 in front of the oxygen. So now you have 1 carbon on the left, 1 on the right, 4 hydrogen on the left, 4 on the right, 4 oxygen on the left, 4 oxygen on the right. I apologize for that. But all I did from the last step is I just added a 2 there. Okay. Keep going. Now the last one is you have to do yourself. This is going to be a little bit difficult, so make sure you recognize that one. This is tough. It says lime water reacts with carbon dioxide to produce calcium carbonate and water. Write the chemical equation below, then balance it. So what you're going to have to do is list down lime water plus carbon dioxide yields calcium carbonate plus water. Then you balance it, so it's up to you. Okay, so you have 2. You follow the same step as we did in number 3, and you should be okay. So the last thing it says, please do not submit anything to Google Classroom. You need to organize these together, keep them in some kind of a binder or something. And the first day we come back face-to-face with face-to-face instruction, then I want you to bring all that in so we can go over this, okay? But please don't submit anything because I'm not going to be sending you grades back. I want you to keep in a packet some way and bring that in when we come back to school on a regular basis. Everybody understand that? So that's what I want you to do. Now, the last thing I want you to do as well is, I have a little thing here. It says there's a different video as well. It's Balancing Chemical Equations by Khan Academy. I suggest you use Khan Academy or Bozeman Science or Tyler DeWitt. Any of those 3 videos will be a perfect way to enhance learning about balancing chemical equations. Anyway, that's it for this first video. I hope you learned something. If not, maybe tomorrow. But anyway, this ends the first day, so thank you very much.